Our today's concern is what is paging, what are the page replacement algorithms, and we will see that 3 page replacement algorithm, and at the same time we will see that how we can compare which page replacement algorithm is the best one. We have started the concept of paging in the chapter 4, and there we have discussed about the definition, but let me go through the definition once again. Paging is basically when operating system divides the virtual memory and the main memory into small units, and those small units are called pages. So the process of memory management by dividing the memory into fixed size of pages is called paging. Okay, now each page is used, can be either in the secondary memory or in the page frame in the main memory. Page is used for faster access to data, because whenever we are using a program, we actually don't use the all the program, we use part of the program, and that's where actually paging comes in. The basic idea is when we divide the physical memory into fixed sized blocks, okay, we call them frames, and when we divide the logical memory into blocks or same size, we call them pages. So here's an idea of how page works. So this is the virtual memory, and we have page 0, page 1, page 2, and so on. Those get stored into the memory. Now, the main concept here of today's class is page fault, a concept that we will learn and we will practice. So first of all, what is page fault? So let's assume you're looking for a page or data, okay, requested by a program, but it's not available in the memory, and it is called page fault. So if you're requesting for, suppose, a data for a program and the data is not available into your memory, okay, it will be called page fault, page missing or page fault. Okay, now the usually results in application being shut down. Okay, suddenly if the data is not available, the program actually crashes. So we want to actually make sure the page fault or this page missing is actually low in number. So this is the idea of the algorithms. Now, so here we have discussed in details what is page fault. The main function of paging are performed when a program tries to access pages that are in currently not mapped to the physical memory, that is our RAM. Okay, the situation is known as page fault. The operating system must then take control and handle the page fault, okay, in a manner to invisible to the program. So basically the program will wait, the operating system will do all the necessary steps needed to make sure the page is there. Okay, so what are the steps? The steps are that first the operating system must determine the location of the data into the secondary storage. So let's assume you have stored the data in your hardware. So if the data is missing, first the operating system have to locate the data, then it's to obtain an empty page frame, because the data need to be stored in a RAM to use as a container for the data. Third step, it load the requested data into the available page, and fourth, update the page table to show the new data. And what is a page table? This is basically like you can say this is a memory where all the pages are stored, and you can see which pages are there or not. So this is a data structure used by the virtual memory system in a computer operating system to store the mapping between virtual addresses and physical addresses. Okay, and finally it returns the controls to the program, so the program can actually resume its work. Okay, now so when a page is missing, okay, what we need to do, we need to actually load the page, right? And to do that, we need to actually use this algorithm that we call page replacement. So the basic idea is same. Let me show it here, that we have this, let me just go to the first example. So let's assume that I have this data structure where I have stored 1, 2, 3, these 3 pages. Okay, and if then I want to load a new page, as I don't have any other space left, okay, I have to remove one of these pages, or I have to replace one of these pages, and this is called page replacement. And the way we do it are called page replacement algorithm. Again, whenever this is your data structures where you are storing the pages, and as you can see that we can store 3 pages. 1 is a page, 2 is a page, 3 is a page. You can store 3 pages at a time. Now, if you want to load a new page, you have to replace one of these pages. Okay, so this is called page replacement. And the algorithms that we actually use for this are called page replacement algorithm. Now, before going to the algorithms, okay, let's see what are the current algorithms we have. So these are some of the page replacement algorithms that we have: first in, first out, optimal replacement, least recently used, not recently used, second chance, and so on. Okay, we will learn the first three. Okay, these three will give us the idea about how this page replacement work. Now, the first algorithm that we'll start is first in, first out. So as you can understand from the name, that whenever we are replacing a page, we will always replace the page that came first, or we can say we will replace the oldest frame. Now, before going to the solution, let us understand the question. Okay, so first of all, this is a FIFO example. That means first in, first out algorithm. What is the reference string? These are a list of pages that you will be using. So first page 1 will come, then page 2 will come, then page 3 and 4. Or I can say in this way: first you will use page 1, or your program will request page 1, then your program will request page 2, then page 3, then page 4, and so on. Okay, then again it will request page 1. So these are lists of page requests that will be done by your program or CPU. Then there are two ways we can calculate the page fault. One is 3 frame and another is from 4 frame. 3 frame means that you will be able to store 3 pages at once. 4 frame means you'll be able to store 4 frames at once. And what is a page fault? Page fault means that you will request a page and that will not be available. That will be called page fault. So without any further delay, let's go to the algorithm. So here we start initially with an empty box. Okay, so initially this is our first case. Okay, let me draw it again. So initially we have an empty data structure of 3 frame. We are doing first in, first out example using 3 frames. Okay, so first our program will request page number 1. Is it available? No, right? So the page fault will be 1. Then every time a page is requested and it's not available, we will increase the page fault by 1. Then what we'll do, we'll go for the next one. So again, our program is requesting page number 2. Is it available? No. So page fault, you see page fault increased by 1. Okay, and the page 2 is loaded into the memory. Okay, then again we're requesting page number 3. Is it available? No. So page fault will increase by 1. You see page fault has increased 3 for all the 3 frames. Now the current page fault is 3. So it's basically a counter. We are counting the number of time we are actually not being able to locate pages in this memory. Now up to this it was fine. Whenever we needed a page, we loaded them into the memory. But now my program is requesting page number 4. Now, is it available into the memory? First of all, the answer is no. So page fault will increase by 1. This is number 1. So it will change here, +1. Okay, because 4 is not available. Secondly, we have to replace one of this, okay, because there is no empty space. Now, which out of this 3, which one came first? We can see that 1 came, 2, 3. Obviously, this one came first, right? So what we will do, we will replace 1 with 4. And this is the concept of first in, first out example. So if I go to the next slide, you see this is the oldest page. This page 1 came first, so we replaced this one. Then again we needed page 1, and again page 1 is not here. Okay, for the next step. So out of the pages we currently have 4, 2, 3. Which one is the oldest or the came first? Obviously 2, right? If you get confused, how do you know which one is the oldest? Just look at this list. So currently we have just underline 4, 2, 3. So which one is the oldest? 2. So that means we have to replace 2. So we're actually looking backwards. Okay. So then if I go to the next slide, you can see. So again, the page 2 is missing. So we replaced with 1. And again, you see the page fault increased by 1. And then we need again page 2. So again, the page 2 is not here. Okay, so we have to replace one of these 3. So again, which one is the oldest one out of 4, 1, 3? 4, 1, 3. 3 is the oldest one. That means we will replace 3. So 3 is replaced. Okay, and then after that we need 5. So and now 4 is the oldest one. So we will replace 4, and here the page fault will increase by 1. And then you see next we'll be looking for one. Okay, so one is actually one is already present, so that's why this is looked green. Okay, so there will be no page fault. And then we're looking for two is already there. Okay, so no page fault. Then we're looking for three, but three is not there, so we actually replace the oldest one out of this three. So 512, 512, 5 was the oldest one. So wait, I think there's a mistake here. So out of this three, 5, 1, and 2, okay, 5, we brought 5 in during this time, 2 in this time, and 1 in this time. So obviously 1 is the oldest one between this, so 1 will be replaced. And then if we go for the next one, 4, okay, so again you see out of this, the currently we had 5, 3, 2, so 5, and then 3, and then 2. So 2 actually came in this time. Okay, so we will actually replace it with the 1. Now again, what we are doing, we are looking for the oldest one. Okay, so when it came first, we have to always keep track of it. So whenever you're solving it in your script, what you can do, you can actually use a mark here. Okay, otherwise you might, whenever you're rushing, you might also made a mistake like this. So anyway, let's go to the next one. So this is the basic idea, that we always replace the oldest frame or the oldest page. So we see that which page came when, and every time we do it, we just replace the oldest one. Now the total page fault, that is, as you can see here, is 9. The total page fault is 9. So what happens that this is your result. So whenever you are given a reference string, you will calculate the total page fault, which is 9. Now, if I actually change the number of frames, okay, if I change the number of frames to 4, logically it says that if there is more frame, that means if there is one more empty space, okay, the page fault should be less. Okay, the page fault should be less. But you see, if I do it for the 4 frames, okay, what will happen that after doing the calculations one by one, whenever we are using the 4 frames in first in first out algorithm, the total page fault is 10. Okay, so this is called Bilady's anomaly. Okay, that means in first in first out replacement algorithm, even though normally more frames, more memory means that the more pages can be there. Okay, so there should be less amount of page fault. Okay, but here the problem occurred that it led to a anomaly that is called Bilady's anomaly that happens in the first in first out algorithms. And this is a diagram that actually helps us to understand this. So when we have in number of frames is 1, that means we can only store 1 frame. Okay, the number of page for this reference string, the page fault will be 12. When you have 2 frames, page fault will still be 12. When you have 3 frames, the page fault will be 9. So this is 9. Okay, but when we have 4 frames, the page fault will increase by 10. And but for the rest of it, the page fault will decrease. So if we have number of frames are 5, the page fault will be only 5. If the number of frame is 6, the page fault will be 5. So normally what happens that if you increase the number of frames, the page fault decreases. Okay, only the exception of in first out, the Bilady's anomaly. Okay, so this is the one anomaly that we can see. So try to remember this one. For the rest of the cases, it's normal because it's logical. If you have more memory here, okay, the more pages you can store, and the more pages you have, okay, next time whenever you need a new page, you can just take it from here. Now the next algorithm is again the simple one. Let me just jump to that one. Where is it? OPT. Here. So the next one is called optimal replacement algorithm, that is OPT. So what it's actually one of the best algorithms for page replacement. Okay, what it does, it actually, first of all, it gives us the lowest, as you can see, lowest page fault rate of all algorithms. So if you use this algorithm, the number of page fault will be the least amount, okay, the lowest amount, and it will never suffer from Biladi's anomaly. Okay, so there will be no anomaly like this. So if you increase the number of page frame, the page fault will decrease. Now, so what is the idea of this optimal page replacement or OPT algorithm? We replace the page that will not be used for the longest period of time. So here what we do, okay, in the reference stream, we actually look into the future, that in future, my program will request which page. Okay, so we look into the future and we replace the frame that will not be used for the longest amount of time. So let's see how it works. So first we'll need page 1 as well, so page fault is 1. Then we'll need page 2, so page 2 will be loaded as well. We'll need page 3, page 3 will be loaded. Okay, now it's time for replacement. We need page 4, but page 4 is not here. Okay, so we need to replace one of these three. So what we will do, we'll look into the future, okay, that what page request we will have in future. So if you see that in future, okay, in the check forward, we will need page 1 will be needed here. Let me mark down here. Page 2 will be needed here. Oh, wait a second. Yes, page 2 will be needed here, and page 3 will be needed here. So which one will not be used for the longest period of time? 3. See, so 3 is actually the farthest in the future. Okay, so what we will do, we'll replace 3 and we'll add 4 here. Again, one more time, what we will do, out of all the current pages we have, we'll first see that 1 will be used here, 2 will be used here, and 3 will be used here. So out of these pages, which one will be used in the farthest or the long will not be used for the longest period of time? That is page 3. Okay, so we will replace the page 3. So let's go. So again, we replace the page 3. Next one is page 1, so it's already here. Then we need page 2. Page 2 is already here. And then we need page 5. So again, we need to make a replace, okay? And the page, whenever we need page 5, that will also increase the page fault by 1. So every time a page is missing, we increase this value, okay? So don't forget to do it. Now, page 5 again, let's see that we currently have page 1, page 2, and page 4. So page 1, if I look into the future from this position, page 1 will be used here, page 2 will be used here, and page 4 will be used here. So obviously you can see the 4 will not be used for the longest amount of time. So that means we will replace 4, and you see we have replaced 4 with 5. And then again, page 1 is already here, then page 2 already here. And then you see the another type of situation. See, whenever we are trying to insert page 3, okay, now in future, if you look into the future, okay, which one will not be used in the longest amount of time? There is no reference of 1, there is no reference of 2, and there is only reference of 5. So out of 1 and 2, none of these pages will be used in future. So in that case, which one we will replace? We will replace the oldest one. So you see here, we had 4 and 5. So 1 will not be used because it has been came first. So we will replace 1. And finally, the rest 4 is also here. So 4 will replace 2, okay, because it is used after 3. And finally, we have this one, okay, the page 5. So in general, this algorithm, okay, only gives us page fault of 7. So this is obviously better than the first in, first out that we learned. So the total for 3 frame, the page fault is 7. If I increase the number of frames to 4, okay, you will see the page fault will decrease much. Page fault becomes 6. So there is no Biladi's anomaly, we have confirmed. So if we increase the frame, the page fault will also decrease. So this is all about our OPT algorithm. And finally, we have this last algorithm that we call LRU, least recently used. So what we do in this one, we just look into the past and we see which one we didn't use for the longest amount of time. We replace this algorithm. And that's what I was actually referring when I was using first in, first out. So in the first in, first out, we replace that. We replace the page that is the oldest, but in this one we replace the page that has not been used for the longest amount of time. So let's see how it works. So initially okay, let's so initially we have, okay, so 1, 2, 3, 4. So first of all, I'm doing it for the 4 frames right now. Okay, so first of all the 4 frames are here, so we didn't need to do any replacement. Okay, then we need page 1. Okay, so the page 1 is already there, so no page fault. We need page 2. Page 2 is already there, so no page fault. We need page 5. Now this is, you see, this time page 5 is not here. So what we can do, okay, we need to replace that was used in the or that have not been used for the least period of time. So if you look in the past, so we have currently, we have page 1, we have page 2, we have page 3 and 4. So which one is have not been used for the list? Oh, sorry, page 2 have been used here. Let me clear it again. So you're looking for page 5, and we have to replace one of these 4. Okay, so out of this 4, page 1 have been used here, page 2 have been used here, and page 4 have been used here, and page 3 have been used here. So out of this 4, which one have not been used for the longest amount of time? We can see that is page 3. So we will replace page 3 with 5. Okay.